everyone. This is the 15th session on numerical analysis of BSc 5th semester. In this session, we shall discuss one more problem on Newton-Raphson method, which is one of the most important and easy method of solving non-linear algebraic and transcendental equations. So in the previous session, we have discussed the methods, that is the steps involved in the Newton-Raphson method in detail, and we have solved one example using Newton-Raphson method. In this session, we will be able to understand thoroughly the Newton-Raphson method and the steps involved in this method, and we will solve new type of problems using Newton-Raphson method. So let us consider the first example on Newton-Raphson method. So this is the example over here. You please look at this, try to read the question. Here we have to show that the iterative formula, we know the iterative formula of Newton-Raphson method, but in this case we have to modify that formula, and we have to show that iterative formula for finding the reciprocal of n. So n is a number, reciprocal of n is 1 by n. So what is the iterative formula for finding 1 by n? That we have to find, and we have to verify that, we have to show that iterative formula is this particular expression, that is xi plus 1 equal to xi into the bracket 2 minus n into xi. And after arriving at this expression, we have to find the approximate value of 1 by 31. That is, if we get the expression for this, then by using this expression we should be able to get the value of 1 by 31. And how that process proceeds, I will explain you. You please follow the solution. So first let us assume that reciprocal of n. We want to have the reciprocal of n, iterative formula for that. So 1 by n, you take it as x. So x, 1 by n is unknown. So unknown we usually denote it by x. So x, which is the unknown, that is to be taken as reciprocal of n, that is 1 by n. And you rearrange the terms. If you take reciprocal of both sides, you will get 1 by n. Reciprocal of 1 by n is n, that is being written on the left hand side, and the reciprocal of x is 1 by x, that is being written on the right hand side. In the next step, you take this quantity to the left hand side. So that we have to do. So let me once again tell you what we have done actually over here. We have taken x is equal to 1 by n. In the next step, we have taken reciprocal on both sides. 1 by n reciprocal is n, x reciprocal is 1 by x. Then in the next step, we have taken this quantity to the left hand side and got n minus 1 by x on left hand side, and on RHS it is merely 0. So this is the equation we are having here, and in this equation whatever LHS is there, that we have to take it as f of x. So let us take it as f of x equal to this LHS here, and now after finding f of x, we want f dash of x. As far as the Newton-Raphson method is concerned, we want f dash of x in the denominator. So therefore, let us find out f dash of x. So simply by differentiating this with respect to x, n is a constant, its derivative is 0, minus as it is, 1 by x differentiation is minus 1 by x square. So minus minus plus here, and it is 1 by x square, the derivative of the RHS, that is f of x. It is f dash of x. We got it as 1 by x square in this case. Now we are having the Newton-Raphson formula. The Newton-Raphson formula is here, and the Newton-Raphson formula is to be modified. How we are going to modify that I will show you. Xi we keep it as it is, f of xi, we have substituted this value over here. F of xi is here in x, wherever in f of x, wherever x is there, replace it by xi, it is here. In f dash of x, wherever x is there, replace it by xi, you will get this thing. So that is we have substituted over here. Now let us simplify This thing, after taking after cancelling and taking LCM and all, if you simplify, the expression is going to be this thing. So what we have done over here, please try to see what the simplified form is. If you write systematically, we got xi equal to xi plus 1 equal to, you look at this formula, xi plus 1 equal to this thing we have obtained, and let us rewrite it in a systematic way and take it as a formula. So this is the new formula. We got xi plus 1 equal to xi into the bracket 2 minus n of xi, n into xi. That we have done here. You can observe over here, this is a very simple simplification. Xi minus of minus, you please observe how the simplification is going on. E minus xi minus plus xi into 1 xi, x plus xi is 2xi, that is over here 2xi, minus n into xi square minus n into xi square is here. So this simplification is looking like this. So therefore now this expression is going to serve as an iterative formula for finding the value of 1 by n, because this is going to give us the value of the root of the equation f of x equal to 0. What is f of x equal to 0? F of x equal to 0 is n minus 1 by x equal to 0. N minus 1 by x equal to 0 means what? N equal to 1 by x. N equal to 1 by x means what? X equal to 1 by n. So this equation, this formula is giving us the value of x. So what is the value of x? It is 1 by n. So ultimately, with the help of equation number 1, that is the iterative formula, we are going to get the value of x, that is nothing but the value of 1 by n. That is the reciprocal of n we are going to get. That is our objective in this case. So we have completed half of the solution of the problem. So what we have done, we have got the new iterative formula for finding the reciprocal of n. Now the same thing I have written. This is the iterative formula for finding the root of the equation f of x equal to 0. What is f of x? It is n minus 1 by x equal to 0. Now n minus 1 by x equal to 0 means n equal to 1 by x. N equal to 1 by x means x equal to 1 by n. So that is the reciprocal of n. So that equation, that formula, this formula is going to give us the reciprocal of n. So this is the iterative formula for reciprocal of n we have obtained. Now let us use that same expression, this same equation number 1 with a suitable value of I to find the value of 1 by n. This work has been assigned to us, additional work. We have to find the value of 1 by n. In order to find 1 by 31, sorry, it is 1 by 31. Actually 1 by n we were speaking about, and in this case n value is 31, because we are finding the reciprocal of 1 by 31. So 1 by 31 means n here is 31, because x equal to 1 by n we were having. In this case x is equal to 1 by 31 means n value is 31. So we are substituting n equal to 31 in equation number 1, and then we are going to get here n value is being substituted and everything is as it is. Now we have to choose the, see, when we substitute I equal to 1, when we substitute I equal to 0, we will be getting x1, the first approximation for the desired value of x. Desired value of x means desired value of 1 by 31, that is we are intended to find. Now to get the first approximation for x, we have to substitute I equal to 0, that gives us x1. Here I equal to 0 means I plus 1 means 0 plus 1, that is x1 we are going to get in terms of x0. You please observe x0, I equal to 0 we are substituting, therefore x0 into the bracket 2 minus as it is 31 as it is x0. So we want x0. What actually x0 is? That is very important. We have to choose the initial approximation x0 equal to 0.03. Why it is so? You please observe something I have written over here. 1 by 3 is nothing but 0.3, we all know. 1 by 3 is 0.3, 1 by 30 is 0.03. When 1 by 30 is 0.03, this is very simple. 1 by 30 is 0.03, therefore 1 by 31 is very close to 0.03. So 0.03 can serve as the initial approximation, the rough approximation for the value of 1 by 31. Therefore, x0 is being chosen as 0.03. This observation you have to do by yourself. It remains on you. It is your duty to guess it. So it is in a very simple way I have made this type of guess, and I have chosen 1 by 31 is near to 0.03, and that 0.03 I have chosen it as x0, and let us use that x0 over here in this formula. So x0 is here, x0 is here, and after simplifying the right hand side using the calculator, scientific calculator is preferred and that is allowed to you, and you can use it. The final answer will be 0.0321. This is the first approximation we have computed. Now we shall use this in the same formula when we write I equal to 1. When I equal to 1 in the same formula, when we write I equal to 1 in the same formula, we get x2 value in terms of x1. So x1 is available here. x1 we are having in our hand, and we shall be using that x1, and we are going to get the value of x2. You please observe the value of x2 is x1 into bracket 2 minus 31 into x1 by using the same expression. You please see here. Wherever I is there, if you put 0, 1, we are going to get this one new expression, and here x1 value is available here. This is x1 value. You substitute it here, and after simplification you are going to get this value. So 0.032 up to 3 places of decimal, both the answers are correct. Even then, I request you people to proceed for one more step. So I equal to 2, if you substitute, you will get x3, that is the third approximated value of x, and that is the same formula number 1, RHS. Substitute the value of x2, which is being computed in the previous step, that is 0.03226, and substituting this and simplifying this entire right hand side using the calculator, the final answer for x3 is going to be 0.0322. 0.0322. You can observe up to 4 places of decimal. 1, 2, 3, 4. 1, 2, 3, 4. Up to 4 places of decimal, the two values x2 and x3, they are correct. They are same. So we got the solution correct to 4 decimal places, and therefore we can stop at this point, and we can say that the solution which we obtain in this step is the required value, is the required solution. Therefore I'm concluding here like this: since x2 and x3 are same up to 4 decimal places, the value which we obtain in this step, that is 0.32258, x is equal to 0.32258 is the required value of what? Of 1 by n. What is n? N is 31. So the value of 1 by 31, is now we have computed it as 0.032258. So this is how we have used the Newton-Raphson method to find the approximate value of 1 by 31. Not necessarily 1 by 31. You can find 1 by 100, 1 by 1000, 1 by any number. You can find with the help of the same iterative formula, provided you know the initial approximation x0. It is very simple job. I hope you understood very well. So with this, let me conclude. So I request you people to solve more and more examples of this kind. So many examples are available in my book. Please refer the book. Here are the examples. You please go through the examples and you can really understand the concept very well. And I request you people to look at some of the question. This is one assignment question I have given to you. What is the question here? Show that the iterative formula for finding the square root of n. You please see here, we are in this case finding the square root of n. We are finding the square root of n. In the previous case, we have computed reciprocal of n. In this case, it is square root of n, whatever it may be. The procedure is very much similar. So square root of n, the iterative formula for that is something like this. Again, this is going to be the formula which is derivable from the Newton-Raphson formula. That is xi plus 1 equal to xi minus f of xi divided by f dash of xi. From the same formula, we can get this expression. After getting this expression, it is asked you to compute the approximate value of root of 35. So in order to find the value of root of 35, what is to be done? You put n equal to 35 in this expression and use the initial approximation. You have to do the initial approximation. What should be x naught? That is left to you. You can very easily guess it, because root 36, you know, root 36 is 6. Therefore, root 35 is something which is closer to 6. So with that approximation, you can start and you can use same iterative formula and you can get the approximate value of root of 35 as 5.916. You please observe, root 36 is 6, root 35 is 5.9 something. So this is very simple job. You please do it. And with this, let me conclude. And I thank all of you for being with me. And once again, I request all of you to do further reference using my book. It is here, using Mathematics 5C Numerical Analysis. It is now available. Please look at this book and try to have a command over the subject. Thank you.